1 hour.
Okay, okay. Okay, the floor is yours, hocam.
Yeah, thanks for the invitation and the kind introduction. I am Hürriyetoğlu. I work mainly on text processing in various domains. And I would like to tell you about some developments. I have been in the field maybe for 15 years, and a lot has changed in this period. Therefore, first I would like to provide you an overview of what happened, what is happening, and at the end I will give you some practical tips and a notebook. We will go over it together, and some tasks for you to go over, at least to think about. Normally, for natural language processing, in 50s or 60s, it started with understanding language. So what language linguistics tell us about language? So we could encode it in a computer or in software. So the computer would mimic the language understanding, language generation. First, because our knowledge was limited about language and linguistics, forecast were like, okay, in 10 or 20 years, we will solve the NLP or machine translation. But over time, it appeared to be, it is not really hard. Anyway, language consists of morphology, syntax, semantics, pragmatics, and this is what is visible in a sentence or in a document. We started the analysis by saying, okay, what is a token? What is the post-text, the function of the words, like subject, object, or adjective, adverb, and then which words affect other verbs, or what is the main part of a sentence, the verb or the adverbs contribute to the meaning of the verb in a sentence. First, we understood those, so we formalized them. There's many formalizations, but we can say just we formalized them. The next thing was trying to understand how is the language is used in real life. So we need samples of the language. Then we create language resources, corpora. We collected list of verbs, list of place names, list of first names, a lot of things that could help us to encode the language in a software program. It was a formalization era. And as a software developer would use these files and try to parse the sentence, or would try to create scenarios of how a sentence may be dissected in parts. So the meaning representation would be created. At the end, the task would be, can we identify named entities? Can we identify place names? Can we identify emotions or semantic roles after all these steps? I talked about this. It can be even summarization or machine translation. Machine translation is, we can say it is mother of NLP tasks, because the most intensive effort was spent to translate between English and Russian, English and Arabic. It was funded by DARPA, US military, and you can see it is some sort of politic, what is supported or not, or in what direction. There is still a lot of support in this line, IARPA, for instance. Just a little example to show you how it may start even from speech, the signal, the phonemes, the morphemes, words, sentences, meaning. And then you would start to construct a logical representation. This is first order logic. And in first years, we were thinking this must be enough, which turned out to be not. We build systems, we are enthusiastic, just embed as much as possible, put all dictionaries, put all entities in your system, and it must work. And at the end, for certain domains, limited domains, it worked. But again, there was always something that was hard to, or something new, and the word changes, new meanings to the words coming, or new uses. We see this in the user-generated content, for instance. Anyway, it worked for certain specific settings, and people made money. They got publications, a lot of things, but only until recently, the NLP was okay, usable. Maybe even we can say with starting with BERT or ChatGPT, it can be even more complex. This traditional way of doing it is highly optimized. You can understand why the prediction or the decision is made. It is explainable. You can track everything in it, and you can debug it. So if a named entity is not recognized, for instance, maybe the first name is not in your lexicon, and then you would go there, put it in your lexicon, and then it would work. Or some name is normally both is used both as a first name and another normal noun. Then again, you would create another layer of rules and fix it. It is very easy to start. You can write rules because it is what you see. And it is very tempting to really just start writing rules because this is what you see. After a little bit of language understanding by yourself or linguistic education. And for certain domains or specific types, you are happy that your rule works. Or you can just improve your language resources, and then it works. But when there is a new term, for instance, COVID-19, then it starts, you can't keep adding new terms. Or you need to employ really large teams of linguists, software engineers, and NLP experts. I worked in this kind of settings, and like Microsoft spent a lot of money in this paradigm, and they make money from these products. But since 2000, and in an increase in pace, machine learning, which brings a bit more automation, like, okay, why we are trying to formalize it if it is changing or if we can't cover everything anyway, and why we should have a linguistic expertise for everybody. Let's automate it and create algorithms that would understand these patterns. And it just increased because it is, again, tempting to just tell the computer, tell me what is in this text, what is the topic, for instance, what are the named entities. Or if you are in a scenario that is not possible to really write all rules in a multilingual setting. For instance, if you want to capture information from 50 languages, I did it in European Commission, you can't write that many rules. You have money, you start to write rules, but at the end, you're stuck. A new global event happens, Russian war. Many new entities are there, and you can't keep employing people. European Commission does, by the way. So, but it is really expensive and one-time effort. Anyway, the more automation is there, the better. With automation comes learning from data with a massive amount of data, and algorithms should be more efficient, or both time-wise and what they learn from the data. A lot of investment, like it started with statistics, like what is there in a group of documents that is not in another group of documents. It is PF-IDF, for instance, or what is in a what is the term space today, and what is the term space tomorrow. Or I work on historical text processing as well. What was the ingredients of the text years ago, like in 16th or 17th century. It started with statistics and with optimization techniques. Now it works even better. One of the main tasks is the spam detection, like how a machine can tell whether an email is a spam, for instance. And based on the words, it was naive based. It started with then support vector machine, which is a bit more efficient. It learns from the examples. And here, the effort a human should spend decreases. But at the end, again, even the effort decreases, there is always new aspects that are not known to the computer, because the world is changing. The algorithms weren't really capable of encoding everything, not every domain, not all scenarios of a spam. So we had to be a bit more adaptive. It is just an idea of the machine learning. You somehow transform your data feature selection, feature extraction, feature selection into XY axis, and then you try to see what is the pattern. This is your first model, this is your second model, and you try to find the optimal model. This is the optimal here. It is the least erroneous prediction you can get for these data points. With this one, you would get 0 error, but for any new data point, your error would be much higher. So there is a trade-off there. And maybe history of machine learning is displayed a significant role in history of machine learning. This is another thing. If you can't have a linear line, you will transform your space, let's say vector space, and try to have a boundary between your two different classes. This is support vector machine, and it is like a reason why it was successful. And here, in addition to statistics, linear algebra become very important. A lot of techniques were borrowed and being used from linear algebra, because at the end, you end up with a vector space. So how would you transform it? How would you filter it? How would you have a pattern, find a pattern in it? This is a very simple data for examples, but it may be in any shape. This is only a couple of examples. Just imagine the data you came across on different platforms or from different sources. And this is one of our job, like, okay, what are the patterns? Can we, for a new data set, can we find the pattern? Maybe it is one of those or not. Topic modeling, I will come to it, but there is two aspects, like when you have one document, what is its topic? Is it a spam, or is it about environment? Is it about science, or technology, or religion? Or this is like one document, one topic mapping, but it can, mostly it is about one document may consist of multiple topics. So what topics are mentioned for a certain document. At the beginning, you may say, okay, so what? This plays a crucial role in information retrieval. When you have a library or when you are on the web searching for information, there is billions of documents, and which document is related to your need. Then it may be running behind the scenes. You may not recognize it is running, but this is what is done to bring relevant information for you. You can just for seeing or visualizing or grouping things, there is various techniques. It starts with clustering, a bit more performant TSNE, a bit less performant, but it served a lot of benefits, let's say. LDA, this is LDA, we call it, latent Dirichlet allocation. There is many names. I will try just to mention them, and based on your needs, you will discover them. After a while, deep learning came, which is one step further. So you don't need to do feature extraction and feature selection. The algorithm does it on itself. So it chooses the features that optimizes an metric, performance metric, and on the basis of various iterations, at every step it gets a bit better. And the way it is getting better is, again, optimization theory and optimization science. And we call it like gradient descent. It is a basic formula, but it is run so many times to get to the trying to find the optimal point in this feature space. Vector space, feature space are same in this context. Yeah, that is it. So I said we had words. We have maybe multi-word expressions, or we have lexicon or language resources trying to decipher what is happening. But mostly the meaning of a word is determined by or understood by us, by human, by the other words that co-occur in the sentence. So we disambiguate language using this other clues, maybe the context of the use. So therefore, we need to model this. So there is information there, and instead of just using a token, a word like here, like learn or static, we would benefit from the words around to understand it. There, word embeddings came, so we have a way of creating the feature vectors, or we have the way of representing each word with the information that mostly co-occur with it. So then we have a better understanding of this word, for instance. It is not just a sequence of these 5 characters, not anymore with word embeddings. This can be applied similarly to character embeddings. And here it is based on, okay, I am learning a better representation of this word. But this was the second step in 2013. And after a couple of years, our algorithms or compute power and our knowledge helped us to say, okay, let's learn these patterns a bit more dynamically. So because static context doesn't model multiple meanings of a certain word, so it changes based on a context. Let's encode this information as well. And then we have pre-trained context vectors for sentences now. You can learn all these occurrences and how is the meaning, or in comparison to other words, they have a distance in the vector space. This is the only thing we know. There is a distance between them, and how much distance. And then all these terms really related to these concepts like transfer learning. We first learn a lot of word knowledge from a corpus for the words and how they co-occur and how it changes. And then we use this information for our tasks. So now, instead of only knowing just tokens or just the tokens and the mostly co-occurring terms, we know the word knowledge as well, as much as our corpus, base corpus allow us, and it helps. In NLP, mostly, if you have more information, you need to find the source of the more information to get better performance. If you are in a domain, you find domain knowledge because machines will not find anything from nothing for you. Just a couple of examples. I keep saying vector space. Actually, it is the central concept. And the representation in a word embedding scenario, the static one, man and the woman are separate. Queen and woman are closer to each other. And there is, this is the, you can start to do vector arithmetic. The difference between China and Beijing, which is a country and its capital, is quite close to difference between another country and its capital. So we start to encode information. And semantics start to be a bit more important. Before it was syntax or morphology or lexicology. Now semantics, which is a bit higher level, came into play. For the context, we started to understand the sentences better, an occurrence of a word in its sentence. So we are not talking about one single token anymore. In this sentence, the representation of the deposit is different than the representation of deposit in another sentence, for instance. Before, it was the same for the static word embeddings. And then it just gets more complicated. It is all vector processing or linear algebra. At the beginning, it may seem to be complex, but actually it is a couple of lines in your software when you know some NumPy, for instance. Different structures, people just start to search for them. I have a couple of links for you to explore. Yeah, I already mentioned this stuff. I was about to talk about BERT as well, because BERT is the really, I will go over it a bit quickly. And the web is really full of a lot on BERT. It has some sisters. Elmo is actually preceding BERT. Everybody thinks it started with BERT, but Elmo precedes BERT, and there was 2 or 3 other libraries or approaches that were trying to get this information. But the BERT is the first one to do it quite in a performant way, computationally. It can parallelize things, and the performance metric, learning from the data was, so then it was the winner. Although in some scenarios still you can use other Elmo. We had a paper about this. I will refer to you to these slides. I already shared them with Akınoca, and the web is full of them. but it really started with BERT, and it is still the state of the art. Although there have been additional improvements, Roberta is a bit more optimized or more mature BERT, all these hype you are hearing, actually it is a reality, GPT, but BERT is still quite relevant to all of us, although it is 5 years old. Yeah, it just did much better than others when it was introduced. Yeah, that is it for now. Content-wise, I will go to the code. Any comment or question?
No, hocam, nobody has questions, so we can just go to coding.
Okay. So I want to show you BERTopic. I borrowed the official tutorial and I fixed a couple of things or added a couple of things. But actually the official one is a bit old to be, let me restart it. And it has been improving, adding new features that are really very good timing to add this kind of features. Like multimodal topic modeling. Until it is, I have its explanation, so I'm trying. Normally, if you ask around, it is LDA. Everybody using it, they are understanding it. Even it is not the best, people understand it. So it is a common approach, so therefore it is being used. And it is still relevant for some scenarios if you don't have time to wait for BERT, for instance. Anyway, what we call the topic, when you have documents, let's say 1,000 documents, and you see the words, you can observe the words. So what latent combinations of these words are there, which we call topic? The philosophical discussion of topic is a very different thing. Here we talk about only a mechanistic grouping of the words. Patterns. Again, this is the canonical example of topic modeling. One of the, I really wanted to share this one from BERTopic, and it is enabled by these deep learning or multimodal approaches, because at the end, even it is a text or an image, at the end it is a vector. So when you have vectors, you can combine them. And BERTopic can do this. I love this, so I wanted to show you, but it is only one thing that is enabled by BERTopic. There is a couple of use cases. Please go and see them. After I talk about this, after I show you the notebook step by step, please spend some time or think about it. The serialization of the models, like you have your language model, topic model, and how would you preserve it for use next day, next month by yourself, or how would you share it with your community? Because it is not a deterministic process. Every time you search for topics, you most probably get different results, although not very much, but you need to take this into account. So how would you share it? I find it the most important thing, although many additional evaluation or other stuff are really, again, important, but serialization technically, practically was the most challenging one, because libraries, version of the libraries play a role as well. Or if things get wrong, you will not recognize that you are not really getting the same representation. In scikit-learn, there was a bug in this line. So when you store it and then you read it, it was random. and it was tricky to understand it, but we fixed it. Anyway, the evaluation is critical. Various transformer representations can be obtained. You can get a representation from BERT, from Roberta, from XLMR, or many others. So how they affect the result, I want you to see it. Just when you read something or you produce or present something, to be aware of the things that may change, or people will, even you are very confident about your topic model, if somebody really know about it, will not take it seriously, and you will wonder why they don't respect my time that I spent to make this model, for instance. So therefore, you should report it as good as possible, understand it as good as possible. This is the online link of the, no, this is an additional one. I allowed this one, and you can double check. But if you Google, there is many. Yeah, this one is the online link to the one I will show you, to my adaptation. But I shared it as an offline copy as well, if the online one doesn't work. Yeah, that is it. Let me go over this one. So our environment is connected. The steps are important for you, so you would know at least which components are there, and you can change or why this works like this and not like this. Their GitHub repo is quite good. It is the GPU is enabled, as far as I understand. In Colab, it is quite practical and notebook environment to install things with its dependencies. So it is installed. We need to restart the runtime. So if in Python, if a library is already imported, here this install does it, and you import it again, the successive imports doesn't have any effect. It just preserves what is there. So therefore, you need to restart runtime. Let me double check. For experimentation, for learning, there is a dataset section. Go fetch something yourself, see its representation, so you can transform your own dataset to this representation and then continue running on your own data. This is a very standard toy dataset, by the way. You import it, you tell the language. Here, the default parameters play a role. So if you look at possible parameters, let me show you in the offline version, it works, but here, let me, okay, then you should go to the official. In the Jupyter Notebook offline scenario, this works. It shows you all parameters and their default values. Here, there is a couple of preset models, so you don't need to say which model it is. There is one single model that is selected and they are using it, but you can change it. This calculate probabilities takes time. If you don't have time or you just want to get the quick result, you can ignore this one. You may set it to false. If you change this to multilingual, it is preset again. A specific multilingual model will be used. And then you can compare the topics extracted. Is the multilingual one work as good as the monolingual one? A couple of years ago, we would say no. So the monolingual one is more specific. It should be working better. But recently, multilingual models outperform in some scenarios the monolingual ones, especially if you have training data from multiple languages. So you can benefit from more information. If you are in a code switching environment, or if the words are not known, maybe the multilingual, if it is not known to the monolingual model, the multilingual model may know some clues about it and make a better decision. So therefore, the answer is not straightforward anymore. It is really, it depends. And this can be a good exercise to compare the performance, not only with your eyes, but using metrics, silhouette score, or there is a couple of other. Even in the same model, because we are using the same algorithm, you may create different topic models because it is stochastic, which means non-deterministic. At the end, you will not. You will need to decide which one to use, which one is better. Therefore, you would need to compare them and do it. Normally, it takes this much time. Okay, I will come to this after. I will assume it already worked. We already have the output. Mostly, a topic is presented with a set of the words, like I just said. You have words, and you are trying to come up with a higher level interpretation of this word set, and they are grouped together. It is similar to clustering, but not that similar. It is more optimized for the language. Oh, we have the topics. We see the most frequent 5 topics, and this is like the -1 are the instances that are not put in any cluster or topic. Let's say outliers or not grouped. Another thing I love about BERTopic, it has a lot of ways or functionalities that helps you investigate things. You can get the terms of the topic. It is game, team, games, players. And this is the most frequent topic. Here, what I am saying, it is one of the really very hard, very tricky concept that it runs again. There is a couple of ways of fixing it, but I'm not sure fixing all randomization is a good idea. It should be done in a controllable way by measuring topic coherencies. You can ask your model about the topics, topic sizes, the topic mapper, or their score. This is the score, actually the main score that is used to put the words in the same topic or not. And the labels, or just get the embeddings maybe for another reason, for another. We have the topics and we keep saying, okay, it is not deterministic, it is very hard to understand, and if you run it again, you will get something else. So the most intuitive way is just to see them. So see what is happening. At least we have some bias toward visualization. We want to believe it should be something. Here you can see like maybe this is one single topic, or there is at least a couple of edges, like 4 or 5 topics it should be. This is the first iteration. You can get the probabilities. Let me come to it. Why this is happening? You see, every time it runs, you get something. Props, and this is 200. Anyway, solve it. Normally, the disadvantage of LDA that makes me really uncomfortable is the need to give the number of the topics. So you have a data set, 1,000,000 documents, and you should be able to say, okay, there should be 100 topics. It should, you can't find the optimal K so easily. There is a couple of more systematic ways of doing it, but it is really not, it feels you, and when you publish it or report it, so you are asked easily, how did you determine the K, the parameter, the number of the topics? But here, and why we all not doing hierarchical clustering, because it is very expensive. It is not scalable for 1,000,000 documents. So we are trying to find our optimal, the trade-off, understand and apply the trade-off for us. Anyway, BERTopic gives you the hierarchy of the topics as well. And you don't need to tell BERTopic to do it from the beginning. Like, okay, there must be 50 topics. No. It gives you the hierarchy as well, and it is only a parameter. You can get the terms. These we all, I think we all have seen these kind of topic models. Which topics are there and how frequent are they in relation to each other? And the topic similarity may inform us. You remember here there was a lot of dots very close to each other. So, and maybe when we label them, we can merge them if we are doing our study for understanding a particular data set, and we are not interested in generalizability and using the model again, and it is we are using only as a tool to explore the data set, completely fine. So then we would want to see which topics are closer to each other, maybe for merging or for our understanding. Maybe we will decrease the K and run the model again if we were in an LDA scenario. Here it would work like this as well, but I will show you something else just in a moment. Here, where is it? You see these scores. And the first one is the most representative one, and then the representativeness decreases. So how fast does it decrease? Is a good information just to understand how the topic is coherent. Yesterday it was like this. Let's see, how is it today? Yeah, this topic is a bit more random. Anyway, the generic pattern is the first terms are like this, and then their importance decreases. This information is important to understand with how many terms we should represent a topic. Here it is a good number, like 5, 6, whatever. Yeah, 5. Maybe 10 is better or 3 is better. So this gives us this information, or with independent of what is better just for our interpretation. Another good thing, after you create this topic model, you can update it with more data. You give data and then it is adjusted. And this suits the board keep changing slogan, or you can update it. You can give n-grams, not just by n-gram, I mean multi-word expressions. Like this is a unigram, each word is a unigram in a word unigram, actually. And if you use this combination of 2 words, consecutive words, then we call them bigrams. And this is the bigram part. And it can be 3, 4, but above 3, it is becoming noise, actually. Actually, we told BERTopic find topics, and it found around 200, if I remember correctly. But in the visualization, we saw it is too much scattered. So let's decrease the number based on our observations. Let's do it 60. And then the picture is much clearer. Okay, the clustering, the pattern is a bit easier to observe. And I haven't seen any library that facilitates this step, so I loved it. So it is a bit clearer instead of a scattered one. Then our similarity matrix is a bit clearer. Look to this one. Okay, let's look at this one. Maybe we understand something, maybe. And look at this one. So like a carpet. So exploration is key, and BERTopic provide you the tools to do it. You have a better topics. There was a very strange topic, a random topic here before. Yeah, we can search for topics. Like you have a new word and you wonder in what topic is it. This is semantic search, and this is one of the very novel things that these transformers or BERT kind of things provided us. We don't have 71 because we decreased the number of topics to 60. For vehicle, it didn't work. Before it worked, so let's. No, it is. Which one is similar? These are the ones similar to it, and the most similar is 3. Okay, let's check the 3. And vehicle is most similar to this topic. Car, bike. Yeah, the stoppers could be removed. So, and the next similar one is 10, 37. These are topic numbers. This is an offline serialization, but I highly recommend doing the Hugging Face one. We used the default topic model, actually sentence transformer, but please go and try these things. So don't use and compare things, because I suppose you will not be working only in English. So multilingual ones may work better for you, or in another language it may work better. You can and the other very good thing about this parameter, it is common to optimize a model, language model ourselves, either from scratch or just make an available one more specific to our own use cases. So then we would use it here, and it would work better because you know word knowledge better for your own scenario. So, and the list is comprehensive. I put the links here. Actually, both are one official sentence transformer library, and the other one is the Hugging Face space for sentence transformers. This change log contains all steps, even the Hugging Face serialization with good examples, and how you do things. So a very good documentation as well, instead of where is the I don't know why that doesn't. Yeah, my Zoom thing. Yeah, change log, and you see all these examples with how you do it as well. What are the components? So there is a lot of information here. You have, and this one, for instance, there was a blog post which didn't include this step, so you need to log in. So please be attentive to this part as well. Yeah, and please look at these two things especially, because when you have a set of words, what is the most important words? Like you saw, like there was the stop words here. You see, the, to, and it. These words doesn't have any topic content. So therefore, you would use this one. And the other very good feature I loved, it can use ChatGPT. You may need a key for it, but naming the topics. We see a lot of keyword sets as topic presented to us, but what would you call it to at least communicate? Anyway, that is it from me for now. In the afternoon, I will tell you a bit more Hugging Face space, this one, and more state-of-the-art things. Where is my save button? This doesn't save anyway. Yeah, any comment or question I would love to discuss?
Hocam, thank you so much. We have one question. Can you come here, because is there a microphone? So try to speak there. See if can you hear her, Hocam? No, try.
Can you hear me? Can you hear me?
No.
Hi. Now do you hear me?
Yeah.
Okay. My question is that since the name of the algorithm is BERTopic, so it should be like very sophisticated algorithm when it comes to topics. But when we see it finds topics with only one word, I wonder if it can find like very like certain topics. For example, if text is about red cars, can it say to us that it's about red cars, not only red and cars? Maybe. Or is there any algorithm making this?
Actually, this BERTopic has supervised learning as well, or semi-supervised learning as well. This may help to get what you want, or ask for this versus others. It may facilitate. The key feature or characteristic of this technology is the vector representation. This vector representation knows a lot. It knows a car may have a color. So therefore, we use this technology, and I didn't want to talk about LDA, although I had to, but we are under time constraints as well. So experiment, this may be your homework, like a classical teacher thing. Look at it and tell us.
I will search about it. And I have other questions. Can I ask? In the presentation,
Ishik has a good suggestion. Try bigrams. It will make pick up it.
Okay. In the exercise, at some place you showed the importance of a topic was decreasing. I couldn't understand according to what it was decreasing.
Those are importance scores of the words, and in their position according to the topic center. So the closest one has the highest score, but the rest exponentially decrease in their scores. And then they are put or sorted according to this information. And this is the key information used to put things together.
Okay, thank you so much.
Yeah.
Any other questions? So, Hocam, how is your time situation? So, in the afternoon, in terms of Turkey time, at 2 p.m., we have another lecture. So, the options are this. We can take like a 15-minute break right now and continue for another hour with you if you want. Or we can stop right now and have a late afternoon session for you after 4 or 5 p.m. Turkey time. Which one would you prefer?
Let's do it late afternoon.
Late afternoon, okay.
Because
So
I need to go to the office as well and have a couple of meetings.
okay, no problem.
But starting 4 p.m. I am available.
Great. So we will return back to Özyeğin at 4 p.m. Turkey time. And then at around 5:30 p.m. We can join you for an afternoon session.
Okay, 5:30 is good.
If you change your mind, just let me know later or something. Email me if you change your mind. Okay.
Yeah, this is my program actually. I will travel back home in the meantime between 4 and 5, and then I will be available at home.
Okay, so let's for now say Istanbul time 5:30.
Yeah.
Now, okay, perfect. Hocam, thank you so much. Let's give a round of applause.
Yeah. Have a good day. Bye-bye.
Thank you.